Welcome back to my channel. So we'll continue on our computer science research experiment, and today we shall be looking at coding up your experiment. Coding is an integral part of any research publications or any project. You just have to write code to visualize your data set. You need to write code, which we refer to as EDA, exploratory data analysis. To design your architecture, you need to write code. To evaluate your model performance, you need to write code. To communicate the performance of your model to stakeholders, or to communicate the performance in a write-up, in a paper, in a visualization format, you need to write codes. So you find writing code as a very integral part of your computer research process. So, excuse me, one of the challenge as a newbie to research is, how do I write code for my experiment? Well, that should not be challenging to you. It takes just time. With time, you get used to how to write code for your experiment. One thing you should have at the back of your mind is there are a lot of codes out there that have been written, and you are highly encouraged to start from those ones. You first start from codes that others have written. You want to be sure that you make use of the vast amount of codes that are out there. Now I'm going to walk through how you can get the best of the codes that can help you. In trying to use existing code, you must also take time to learn the underlying technology of those codes. These days, machine learning, deep learning, AI in general are written in Python-like code. So first, you want to make sure that you take a course on Python, at least on rudimentary Python or C# or Java. I recommend a Python. So once you take that rudimentary course, whether it's offered in your campus or you take it online, do the assignment, do the projects, do the exams, make sure you really understand the programming language. Then as you begin to look up for codes, then it will be making sense to you. Some of it will be making sense to you, not all. And as you continue to do increment studies of certain component that you don't understand, then you become better and better, and you see the way things flow. So if you go on the internet to just search on GitHub for codes, you may not get the best of it. So let me show you what I mean. So let's say I go to papers with code. We have papers with code. Papers with code. It's a website searching for that. So this papers with code. So this contains papers and their code. So let's look at knowledge distillation, for instance. So let's say knowledge distillation. So you want to see papers that have been written on knowledge distillations and the associated codes. So I come in here, I take a look at this paper, and I also want to look at the code. So there are implementation in Python and TensorFlow. Excuse me. So those are the two leading ones. So we come in here, let's say you focus on Python. And that's another thing I would say. When you're just starting, as of now, the two leading frameworks for deep learning, machine learning is Python and TensorFlow. It's highly recommended that you stick to one. It doesn't matter which one you actually start with, just stick to one. Make sure that for the first few months or years of your research, you are only using just one framework. This has a lot of advantage. It will help you to be really grounded in that one. Really help you to understand the nuts and bolts of that one, that chosen framework. You'll be very good at it. And when you're a master of that, which will take maybe 1, 2, or 3 years, done a lot of projects, 2, 3 projects using that framework. And if there's need to switch or to try something else, that will be better. So let's say you focus on Python. So you come in here, go online, see the implementation of Python. I would not recommend this approach for a starter because you might get frustrated. But one, some of what they are talking about may not even make sense to you because the code here, you can clone it in your system and you begin to look, what am I supposed to do? So you want to read me. Some might not even have a good reading. So you might not even know how to even. So this one is knowledge distillation. So I'm even looking for where is the knowledge distillation. Okay. So you might see things that you are just confused about. And it's difficult for you to raise issues. You go to issues, you might not be able to get a response on time, and you might just get stuck. Okay. In some cases, you might see that someone else has asked the same question, how do you get started with it? But that's depending on the generosity of the writer of this paper. If they don't answer, there's nothing you can do. So the best is just to go through existing documentation, what others have asked and what they have answered. And if you're lucky that it answers your question, if not, you can only raise another issue. There's no guarantee of response. So say somebody making a request. Okay. So I find it very frustrating and I just go to a GitHub of a code I'm trying to see to understand it. I find it very difficult. Don't even know how things connect, which folder depend on which. Okay. So it's really challenging for me personally. I don't know for others. So what do you do? Yeah, this is another distillation we're looking at. You come in here and you're looking at classes. You know, how does this even connect? Well, the best approach I would say is a couple of approaches. First, I personally use TensorFlow Keras, and if you're doing the same, you could go to Tensor Keras documentation, come into the examples. You will see codes here that have been written for you neatly with documentation, with explanation. At least for me, I find most of this code here relatable. I can easily relate with that. You come in here and you can see how they have neatly put it separated. So the setup, you construct a class, you see how it's neatly written, you put explanation there. Okay, so this is a better way. You may want to come in here and start with quotes here. Say prepare the data set, train the teacher network, teach the teacher to student, train student from scratch, everything well separated, giving you may not be the best 100%, but at least it's far better than just going to GitHub and not knowing what each code chunks actually meant. And if we start with this, gives you opportunity to open it in Google Cloud platform, Cloud, and you can run the experiment quickly. I'm coming back to this, and you can go to other examples and just read through the codes to be able to know how things work. If not for the architecture, maybe you just want to focus on computer vision and the different type of data set in computer vision. So you might just go through the codes one by one and just, your interest is just for you to just, how do they load data set? So here they are loading data set of cat and dog. So you might just focus on how to load and visualize the data set. So they are cleaning out the data set here, and this is how they generate the object for the data set, visualize the data. So from just top up to this stage, you'll have learned a lot about how to pre-process your data set, not even talking about what to do with it. Go to another one, you will see here that you have another kind of data set, and here the data set they're using is the MNIST data set. So if I need MNIST data set, I can just go through this Keras data set and get it. You could visualize it. Okay, they didn't show that, but at least you know this is your data set. Okay. Alright, we have not gone deep into anything. We're just looking at different data sets that are used in a particular research area. So this is another one. So download the data. So this is a different way. The data is somewhere else here. So it's in tab format, and you download the data set, prepare it for segmentation. You get the gist of what I mean. So, and you could see the data set. No, like that. I'm sure PyTorch do has similar thing, but I am more comfortable with TensorFlow and Keras. But if you go to PyTorch, you just have PyTorch tutorials, you will possibly see similar PyTorch tutorials. So you want to learn the basics. and you will also go through that as well. The data set loading, you can see similar thing to here, PyTorch. For different excuse me, research area, you could also see it here for PyTorch. Okay. Now, so that takes care of some part of your coding knowledge. At least this is much better than just going randomly here. Now, another thing is if you go on ACM, if you have ACM account, you can go to O'Reilly. O'Reilly has a lot of book resources and tutorials that are well maintained. So I open it here. If you come in here and you want books on deep learning, you can see what you mean. There are books on deep learning here. Yeah, it's on PyTorch. Okay. And the beautiful thing about this one is they are well maintained. There are some on YouTube, some on videos, sorry, and you have some that are in book format. And the codes are there, they are well maintained. So for instance, see this efficient deep learning. I have not looked at it before. Okay. But you could be sure that the code will be there. So we go in the first few chapters, it will show us how to get the code. Okay, I think this one does not have much of code. Let's look at another one. Okay. Look at something. Okay. This is for fast AI and PyTorch. So let's look at that. So now this one should talk about the code. There's our code. Use this before, what you will learn. Let's look at the code. Put there. Forward. And that is okay for everyone. Talk. Alright, they put the code here. Should have showed us where the code is. It's normally shown in the first few lines. You should see where the code is. I'm surprised. Okay, let me use one that I have done before, and let's see one that I actually worked before. Okay, so that's the machine learning. So here it did show me where the code is for that. It should normally be in the preface the first few lines. So this is the code base. Okay, it's also a GitHub, but you can be sure this will be well maintained. So if we come into this GitHub, you can tie it back to the book chapter here, because this one will be well maintained. So this is how you can get a very good code base. It's always well maintained. The explanation they did here, you also see the explanation in the book as well. It's detailed. You put it chapter by chapter. So let's say you're working on chapter 5 for detection. So this is on the Jupyter notebook, which is very much better, just like the Keras that we look at. So it's detailed, problem definition, the loading. You see this is neat. How to load the data set, EDA, visualize the data, clean. If we go back to the book, we go to chapter 5 on fraud detection. There's the fraud detection. Yeah, you come in here, you will see that the explanation here ties with the code. So here is getting started, loading it. Okay, packages for loading. So you will see that that's also what it showed here as the packages. Okay, more details will be here on the GitHub, and they are doing the explanation of that. So explaining the code, what they are doing. Okay, right now you combine these two together, it really makes much more sense to you. So this is the same. So the code that generated this, you can see it there, and they are explaining it here as well, up to the model. So the creating the model, checking the model, walking you through the different models. So this is much better, well recommended. You will learn a lot going through your coding using this approach. So no matter what your area of project interest in, you can just begin to start with a code base like this and begin to try things out yourself, try out other algorithms, and begin to look at online documentation. It's an iterative process. Go back and forth and see how they lay out their code, what goes before what kind of visualization tools they use, what kind of visualization tool you too can create and put in your paper. And you see those documentation, the metrics they're using, how they are tuning the processes they're going to improve on their models, and just the flow of things until they get a good result, and most importantly how they concluded on their different experimental algorithms. So what they concluded on. So then you read through this, you play around with those codes, with also what is in the book. Then this will give you a more solid ground in that particular project. You learned a lot on this. So that's for one case study. Then you have case study 2. If we go back here, you see the same. So this for the loan data. So this is loan default using classification. So the same thing here. It was just similar thing they are doing. And this is This is the book explanation of it. All right, so I'm going to stop there for now. That's that about that and coding up your spell. Okay, thank you very much and see you in the next one.